In 1992, astronomers made a discovery that would change our view of the universe forever. They found the first planets orbiting a star other than our Sun. Since then, we've detected thousands of these exoplanets, and they're weirder than we ever imagined. Here's how we find them, what they tell us about our place in the cosmos, and why they might be the key to answering one of humanity's biggest questions. Are we alone in the universe? Our story begins in the early 1990s, when astronomers made the first confirmed discoveries of planets orbiting other stars. This marked the beginning of a new era in astronomy, opening up a vast frontier of exploration and discovery. The first exoplanet detection came in 1992, when astronomers Alexander Wolszczan and Dale Frail announced the discovery of two planets orbiting the pulsar PSR 1257+12. This was a groundbreaking moment, but it was just the beginning. The real game changer came in 1995 when Michel Mayor and Didier Queloz of the University of Geneva detected 51 Pegasi b, the first exoplanet found orbiting a main sequence star similar to our Sun. These early discoveries were met with a mix of excitement and skepticism in the scientific community. Many wondered if these findings were flukes, or if we were truly on the brink of a new understanding of the cosmos. But then we came to a pivotal moment: the launch of NASA's Kepler Space Telescope in 2009. This mission marked the beginning of a new era in the search for exoplanets, dramatically increasing the number of known worlds beyond our solar system. Kepler was designed specifically to search for exoplanets using the transit method, continuously monitoring the brightness of over 150,000 stars in a fixed area of the sky. The results were astounding. During its primary mission, Kepler discovered thousands of exoplanets, far surpassing expectations and revolutionizing our understanding of planetary systems. One of Kepler's most significant contributions was revealing the diversity of exoplanets. We discovered hot Jupiters, gas giants, orbiting extremely close to their stars, super-Earths, planets larger than Earth but smaller than Neptune, and even planets in the habitable zone of their stars, where conditions might be right for liquid water to exist on the surface. Kepler's legacy extends beyond its operational lifetime. The wealth of data it collected continues to yield new discoveries, and the techniques it pioneered have been adopted and refined in subsequent missions. Kepler showed us that planets are common in our galaxy, setting the stage for even more ambitious searches for potentially habitable worlds. With Kepler's groundbreaking work paving the way, astronomers could now turn their attention to an even more exciting challenge: understanding the nature of these alien worlds. After all, discovering these distant worlds is just the first step. The real excitement comes in trying to understand what they're like. When we characterize an exoplanet, we're trying to determine its basic properties, its mass, size, density, orbit, and even details about its atmosphere if we're lucky. This information helps us build a picture of what these planets might be like and how they compare to the planets in our own solar system. One of the most intriguing aspects of this work is the search for potentially habitable worlds. We're particularly interested in planets that are similar in size to Earth and orbit in their star's habitable zone, the region where temperatures might allow for liquid water on the surface. However, it's important to remember that being in the habitable zone doesn't guarantee habitability. Many other factors, such as the planet's atmosphere and the activity of its host star, play crucial roles. Astronomers use a variety of techniques to characterize exoplanets. For example, by carefully analyzing the light that passes through a planet's atmosphere during a transit, we can sometimes determine the composition of that atmosphere. This technique, known as transmission spectroscopy, has allowed us to detect water vapor, methane, and other molecules in the atmospheres of some exoplanets. Another exciting development is the ability to create crude maps of some exoplanets by observing how their brightness changes as they orbit their star. This has allowed us to infer the presence of clouds, detect day-night temperature differences, and even hint at the presence of volcanic activity on some worlds. As we've delved deeper into the study of exoplanets, one thing has become abundantly clear. The universe is home to an incredible variety of worlds, many of which defy our expectations. We've already mentioned hot Jupiters, those massive gas giants that orbit perilously close to their stars. These worlds, with years that last mere days and temperatures hot enough to melt metal, were among the first types of exoplanets we discovered. They challenged our understanding of how planetary systems form and evolve, leading to new theories about planetary migration. Then, there are super-Earths and mini-Neptunes, planets that fall between Earth and Neptune in size. These are particularly intriguing because we don't have any examples in our solar system, yet they appear to be common around other stars. Some may be scaled-up rocky planets like Earth, while others might be water worlds with deep global oceans. We've also found planets that seem to defy categorization. Take WASP-12b, for example. This planet is so close to its star that it's being torn apart, leaving a comet-like tail in its wake. Or consider HD 131399AB, a planet with 3 suns in its sky, part of a mind-bogglingly complex orbital dance. Perhaps some of the strangest worlds are the rogue planets, celestial bodies that wander through space without orbiting a star. These lonely worlds, drifting in the cold depths between stars, spark the imagination and raise questions about how planets form and evolve. This diversity shows us that our solar system, while special to us, is just one example of the countless ways planets can arrange themselves around stars. Each new discovery expands our understanding and challenges our assumptions about what's possible in the cosmos. This astounding diversity of exoplanets naturally leads us to a profound question, one that has captivated humanity for centuries. Could any of these worlds harbor life? This brings us to one of the most exciting and challenging aspects of exoplanet research, the search for biosignatures, signs of life that we might be able to detect from afar. When we talk about the search for life on exoplanets, we're primarily looking for signs of life as we know it, carbon-based life that requires liquid water. This is why there's so much excitement about planets in the habitable zone of their stars. However, it's important to note that life might exist in forms we can't yet imagine, adapting to conditions very different from those on Earth. So, what are we looking for? One key biosignature is the presence of certain gases in a planet's atmosphere. For example, the simultaneous presence of oxygen and methane in an atmosphere could be a sign of life, as these gases would quickly react with each other if they weren't being constantly replenished by biological processes. Another potential biosignature is the red edge, a sharp change in the reflectance of a planet at near-infrared wavelengths. On Earth, this is caused by vegetation, but similar features could potentially be produced by other forms of life. It's crucial to approach this search with caution and skepticism. Many processes can mimic potential biosignatures, and we need to rule out all possible non-biological explanations before we can confidently claim evidence of life. Despite these challenges, the search for life on exoplanets remains one of the most exciting frontiers in science, driving the development of new technologies and missions. While the search for life remains one of our most exciting pursuits, it's just one part of the ongoing exoplanet exploration. Looking ahead, we can see a bright future full of promising new missions and technologies. If you enjoyed this cosmic exploration, be sure to hit that like button and subscribe to our channel for more mind-blowing space content. Don't forget to tap the bell icon to stay notified about our latest videos. And we'd love to hear from you. What kind of exoplanet would you most like to visit? Let us know in the comments below. Until next time, keep looking up and wondering about the countless worlds that might be out there.